This was the objective of what we were looking for in making those homeowners give us some information. We were looking for how long, what was the length of time that it took for them to get hot water before they put our systems on and after they put our systems on. The second one is how much water did they lose? Well, how does a homeowner know? Well, it's easy. We simply calculated where he could turn his hot water faucet on, put a pint cup there. When it got full, he timed that. He knew how long it took, pulls it away, and then he puts his hand on it until he has usable temperature, and then he multiplies the pint. It was simple. They all did it. That was what was interesting, because it was a simple solution. We also wanted to know if they actually turned their water heaters down. Now keep in mind, in 95, all tank water heaters had an adjustment valve that you could go from what they call standing temperature, 110, 120, 130. They had it measured. That no longer is true. You have high, low, and medium. But back then, you actually could measure them in degrees, up to 160 degrees. We wanted to know if, with our system, they ended up turning the water heater down, because we were told that people were doing that. The other thing we ask them is, are you doing this for convenience or for water conservation or energy savings? Well, you know the answer to that. Nobody cared about frankly, they didn't understand what energy savings was in 95. Water savings, it was interesting, but they just hated to wait. So it was always about convenience. That we knew. We also wanted to know the age of the home and the size of the footprint, or the size of the home. What was interesting, out of the 26 homes, we had like a third of them that were under 2,000 square feet that reported. We had almost a third that was a little more than a third, between 2,000 to 3,000, and about the rest of them were over 3,500 square feet. So we had a real good curve mix that we could work with. First thing we wanted to do is the distance of the water heater. What happened was, number one was convenience, without a doubt. Number two was water savings. Number three was combination. This is the group sizes. Went from 13 to 7,000 square feet. This was the average square feet in group one. This is the average square feet in group two, and that's the average square feet in group three. So we averaged it out so we could get some information. This is kind of a database. I do have this available. If anybody wants it, I can get it to them. Okay, group. Well, this is basically talking about the water heater temperature. What we learned was that most of the homeowners turned their water heaters down by over 10 degrees or more, according to their dial. And the reason is because now they had water at a higher temperature, and it wasn't a concern to theirs, and they needed to turn it down because it was actually too hot. Which was kind of interesting, because when you turn your water heater down, that's a calculated saving that we never considered, but it definitely is a major saving on the energy side. This was the houses that are under 2,000 square feet. This shows you, number one was the wait time in seconds that they were waiting for hot water. Number two is how long it took for our pump to move hot water to that location. This is not how long they waited for hot water. This is to get the hot water there, which means we reduced it substantially. And this was the amount of gallons that they estimated they lose when they were waiting for hot water. And this was the temperature setting. Some of them, you can see some of them turned it down considerably. And these were the sizes of the homes. This data shows there were 8 homes, and it shows the wait time. And what I did is I just have it graphed, so you could look at it 2 different ways, showing how long they were waiting and the amount of water they were losing here versus when they had the pump running and the actual water that they ended up losing later. Can you see that okay over there? Okay. This is a 2,000 square foot home. This is with the degree of temperature. They turned them down. This shows the water heater temperatures that they adjusted. This is a cross section showing all of that same information, the amount of gallons that they were losing, the amount of time. This is on the second group of homes between 2,100 square feet to 3,000. This again shows you the wait time, what they were losing and waiting for hot water versus the pump actually getting hot water there. This shows the water heater temperatures. I have no idea where that came from. That shouldn't be there. But this shows the water heater temperature adjustments. That's the same thing. Not a very good picture, but it shows the same thing I was showing you in group 1. This is the 3,000 square foot homes and up. You can see the adjustment in time that they're waiting for hot water was very significant in the savings that we created. And typically that's because the further the pipes, the further the length of pipes are generally bigger, the temperature loss is greater, so they wait much longer for hot water to arrive at the fixtures. This is the temperature adjustment that they made on their water heater itself. The conclusion that we came up with was a very interesting. Now you have to keep in mind this is 1995. I actually did not put much stock into this study at that time because we were in the process of introducing new products into the market, and I really didn't know what they did. I shelved this. I put it in the shelf until about 2 years ago, and then by that time, in the last 12, 14 years, there's been a lot of studies that have been done, and all these guys in here now are studying water. The next meeting, the IAPMO is all about water form. I can guarantee you, up until a couple of years ago, the IAPMO could have given a rip less about water. They're only interested in the energy side savings. Nobody associated energy and water. I pulled this out to see how it matched with some of the studies being done. I was absolutely blown away with the information that we'd accumulated was almost the same as what they're learning today. Nothing has changed. We don't build any houses any differently today than we did 30 years ago, or 40 years ago. They're not well designed. So there's a lot of things we can do to improve that for the water energy side. So that was a conclusion that we ended up with here.